optimizing area and perimeter. So the goal for the following two lessons is the following: to determine the optimal area for a given perimeter and the optimal perimeter for a given area. So let's investigate the first part. How can we get the optimal area? So as always, you can always pause the video to take notes, or you can follow along with us, with the rest of us. So here where it says optimal area, you may be wondering what the word optimal means. Optimizing. In this case, in this particular case, we're trying to get the largest area given a particular perimeter. So on your notes, I want you to draw these rectangles, and they're all not to scale, of course, but the dimensions are important. So okay, so they say calculate the area and the perimeter. All right, so do that for the following. Now we're going to be investigating this. So once you draw these, I want you to write down this question, which says, what do you notice about all of the perimeters? So investigate that first. What about all of the perimeters here? So let's investigate this. You have 4 here, so if it's a rectangle, this is 4. If this is 4, we get 4 and 4, 8. And if this is 8 and this is 8, this is 16. So 16 plus 8 gives us a perimeter of 24. Right? So this is a perimeter of 24, so you can write it down here. Let me just put P equals 24, right? P equals 24. Let's write it down on the side here. P equals 24 centimeters. Just didn't know where to put it, right? Let's say this is 5 and this is 5, right? These are 5, so that's 10. This is 7 and this is 7, so that will be 14. So 14 plus 10, that gives us, well, 24 as well. Hope you can see that. Maybe I can make it larger. So I'm not going to write it down again, but you see where this is going. Calculate this perimeter now. So 6 plus 6, 12, plus another 6, 18, plus another 6, it's 24. So again, all of these perimeters appear to be the same. 9 and 9, 18, plus another 6, that's also 24. And then here we have 2 and 2, 4, plus 20, 24. So all the perimeters are the same. So what do you notice about all of the perimeters? So write down that question. Now you can see the other question too. They are all the same. So you can say, okay, all of the perimeters are the same. Now B, it says, which rectangle produces the largest area? Okay, so let's go back to our rectangles and let's investigate. Now, the formula for the area of a rectangle is what? Length times width. So let's calculate that, right? So what's 8 times 4? Well, 8 times 4 is 32. So it will be 32 centimeters square. Let's see if I can fit it here. 32 centimeters square. Okay, that's what we got so far. Let's go here. 7 times 5 is 35 centimeters square, right? 9 times 3 is 27 centimeters square. 10 times 2 is what? 20 centimeters square. So as you can see, right, all of the perimeters are the same, but the areas are different. Let's calculate this last one. 6 times 6, 36 centimeters square. So remember, optimal area would mean the largest area or given a perimeter. So in this case, the perimeter that they gave us is 24. What's the largest area that we can get with a perimeter of 24? Well, after our investigation is this one, 36 centimeters square. So what can we say about that? First, what shape is this? This is essentially a square. So a rectangle that is closest to a square. I think you see where this is going. Which rectangle produces the largest area? Well, the rectangle that is closest to a square. So let's write that down. All right. And another way to put it as well is that a rectangle whose side lengths are the same. And of course, let's do a small sketch of that rectangle that is closest to a square. So essentially, you see where this is going. Okay, our next question on this, it says, if a rectangle, let me put this on the side, if a rectangle has a perimeter of 40 centimeters, what dimensions will produce the largest area? Of course, if we're giving a perimeter, the rectangle that produces the largest area is the one that is closest to a square. So how would we calculate that? Well, let's collect our data first. They're telling us that the perimeter is equal to 40 centimeters. If we know that the rectangle that will produce the largest area will be that rectangle which is closest to a square, right, and they're not giving us any limits as to how this perimeter can be formed, then what do we need to do? Well, we need to divide the perimeter by 4. So let's do that, right? Divide perimeter by 4, because that will give us what the size of each of these will be, right, of this square. So 40 divided by 4, of course, we know it's 10 centimeters. So that means 10 centimeters by 10 centimeters. And the question simply asked the rectangle, what are the dimensions of this rectangle? So the dimensions will be, so a rectangle with dimensions, a rectangle with dimensions of length equals 10 centimeters and a width of 10 centimeters will produce the largest area. Now, our last question says, why would you want to optimize the area for a given perimeter? Well, because the most area, you want to get the most area with the minimum amount of fencing, for example, if you were working on a garden. So that's just one example. You can come up with many other examples. So you may also be trying to get the largest area. Say if you were in charge of a concert and they give you a certain number of metal dividers, metal bars, I guess, and you're trying to get the largest area to get the most number of people in a concert. That's the same idea too. You're trying to get the largest area with a minimum amount of fencing. The fencing will be your perimeter, and of course the largest area is what you're trying to get with a fixed perimeter.